everyone, so we're on to lesson 3 of trig identities. So this lesson is mainly going to be focusing on making the left hand side equal the right hand side. So now we're going to talk about how to do this through multiplication and division. So as a tip at the top here says, it's easiest if you just try to convert everything to sine and cos and then simplify it that way. So here, prove the following for all permissible values. So we're going to do another t-chart. So you have sine theta, secant theta on the left side. And on the right side, we'll have tan theta. So here, we're going to convert the left side to sine and cos. And I always give students a tip, just work with one side first before you go to the other, and you'll see why in a bit. So here, sine theta is equal times secant theta, and secant theta is the same thing as 1 over cos. And then if you multiply this out, it's going to be sine theta over cos theta, and sine theta over cos theta is the same thing as tan theta. So here, tan theta equals tan theta, left hand side equals right hand side. Easy peasy lemon squeezy. If you wanted, you could also do both sides, and that would be okay, like do both sides at the same time. So here, let's say we stopped at sine over cos. On the right side, if you do tan theta, you know that this is sine theta over cos theta, and they're the same thing. So you could also say left hand side equals right hand side. It doesn't really matter which method you use, as long as the reader could clearly see that the left and the right are exactly the same. One thing I want to note is, let's say you got up to this stage where you have sine theta over cos theta, and you know that sine theta over cos theta is the same thing as tan theta, and I know that. But if you left this at this stage where it doesn't directly say that these two things are exactly the same, then you would lose half a mark. So you need to state or show that. So here, the next question, cosecant over cotangent equals secant theta. Exact same setup. So I'm just going to change the left side first. So cosecant is 1 over sine theta, and cotangent is 1 over tan. Yep. And then now, if we convert cotangent, this is the same thing as, or actually here, just to save space, we know that cotangent is gonna be cos theta over sine theta. So I'm just gonna write that here. So now if we were to simplify this, it's gonna be 1 over sine theta times sine theta over cos theta. And then we see that the thetas cancel, and now you're left with 1 over cos theta. And then here, secant theta is the same thing as 1 over cos theta, and we see left hand side equals right hand side. And that's it for letter B. So for letter C now, what you could do here is, honestly, a lot of students see the 1 and they like to manipulate the 1, but I think it's just easier if you leave it as it is and just try to change the left side first. So the regular setup, tan theta times cos theta over sine theta, and then your little t-chart, 1 on the right side. So I'm just going to break this up. So tan theta times cos over sine, because of fraction rules, since these are all being multiplied at the top, you could just break it up like this. It's the exact same thing. Because this is realistically just tan over 1, right? So here, if we were to convert tan theta into terms of sine and cos, it's going to be sine theta over cos theta times cos theta over sine theta, and then everything ends up canceling. And remember, if things cancel, they're not going to become zeros, they're all going to become ones. So if everything cancels, you're going to have 1 times 1, which is just 1. And then now we see left hand side equals right hand side. So this video is basically just going to be me giving you guys tips on how to manipulate stuff. And honestly, a lot of you could probably figure this out on your own, but I'm just here to support you and teach you how I would approach it. So on to the second page. So here, example 2 is exact same thing. So cosecant theta plus 1 on the left side, and on the right side 1 plus sine theta over sine theta. So I'm going to write in red. A lot of students for some reason think that 1 plus sine theta and sine theta, they think that these cancel and it's equals to 1. That is bad. That's a no. Do not do this. I'm going to get really mad if I see this on a test. That is not the case. You could only cancel stuff if everything is being multiplied, and if there's a plus sign separating something, you can't cancel it. So here, I'm just gonna do the left side first. So cosecant is the same thing as 1 over sine theta plus 1. One thing you should watch out for is, if you're looking at your terms here, we see that the left side has 2 different denominators here, right? Or not 2 different denominators, but they're separated. Versus the right side, they're all one giant term. So our goal here is to try to convert everything on the left side to become one condensed term. But how do we do that? Because here we see that we have 1 over sine theta, right? Plus 1. These are 2 different terms. So an easy way to do this is to manipulate any whole number given to you in a trig identity. So here we have 1. We want the denominator of 1 over 1 to be the same thing as sine theta. And how do we do that? In order to do that, so I'm going to write a little note, we want the same denominator. You're going to multiply this by sine theta over sine theta. Because if you think about it, sine theta over sine theta is the same thing as 1 over 1. They're going to divide and cancel out. So here, we're just going to rewrite this. Now we have 1 over sine theta plus sine theta over sine theta, which is the same thing as 1 plus sine theta over sine theta. Because they're the same denominators, now we could combine everything into one giant fraction. On the side here, I'm going to write in red. Sometimes I see some students write it as 1 plus sine theta, and they write sine squared theta. That is not the case. If you are adding fractions together, your denominator doesn't change. They only change when you're doing multiplication. So here, 1 plus sine theta over sine theta, left hand side equals right hand side. Now for letter B. So here, this is a lot more complicated, but that's okay. So on the left side, we see we have 2 different terms. On the right side, we have just one giant fraction. So same setup. And also, it doesn't matter which side you start with, whether it's the left or whether it's the right side. It's up to you, as long as you're able to prove that both the left and right side will look and equal the same thing. I just prefer doing it this method, but it's up to you how you want to approach it. You won't get docked marks if you choose to do the right side first. Like, for example, here, if I were to do letter A on the right side, you could just change it like, sine theta, secant theta, tan theta. If I wanted to change the right side, I could just do tan theta is the same thing as sine over cos theta. And then if I were to break this up, this is the same thing as sine times 1 over cos, which is sine times secant theta. And then left hand side equals right hand side. So you could do honestly either side, it just however you prefer to do it. So anyway, back to letter C, or letter B, sorry. I'm going to change the left side because I see there's two terms and I just prefer changing that around. So cotangent theta plus secant theta. Cotangent is the same thing as cos theta over sine. And secant is 1 over cos theta. And we want this to be the same denominator. So in order for this to be the same denominator, we have to multiply both by the opposites. So here we're going to multiply this by sine theta over sine theta. And then we're going to multiply this by cos theta times cos theta. So when you multiply this, you're going to get sine theta cos theta plus sine theta all over sine theta times cos theta. So I kind of just skipped a step and I just combined everything into one fraction. But realistically, this is the same thing as, so maybe I'll write it here in case you want to add to your own notes. The step between these two, it would look like cos theta times, oh, I wrote that wrong, hold on. This should be cos. Cos theta times cos theta plus sine theta. So this is the same thing as cos theta over sine theta cos theta plus sine theta over sine theta cos theta. And you just put everything together. Sometimes some students are silly and then they're like, oh look, I could cancel cos and sine, but then you're just back to your second step. So if you see this, don't cancel it because you don't put that there. So here, cos theta times cos theta, that's the same thing as cos squared theta. So remember, put the square here in front of theta. That means cos squared theta. Do not write it over here. This is wrong because you're saying that's theta squared. So here, cos squared theta plus sine theta is all over sine theta cos theta. And then now, left hand side is equal to the right hand side. And then you have to write that little sentence at the bottom. So when you're doing this, honestly it could get pretty frustrating if you find that you're making a lot of mistakes or you can't get the left hand side to equal the right hand side. Try doing it the other way around, like start with the right hand side, or honestly just start over. If you get stuck on a question, do not spend too much time going over it because honestly sometimes it's just easier to have a new fresh start. So here we have another big equation. I'm going to change the left side because I just like it changing everything into one denominator. So sine theta plus tan theta sine theta equals sine theta. Wait. Cos theta plus sine squared theta over cos theta. That's supposed to be a plus sign. So here, I'm just going to convert everything into terms of sine and cos. So we know tan theta is going to be sine theta over cos theta times sine theta. And then that's the same thing as having sine theta plus sine times sine is sine squared theta over cos theta. And now we have different denominators, so we're going to multiply by the opposite denominator. So this is going to be multiplied by 1 times 1, and this is multiplied by cos theta times cos theta. So here, you don't have to write the red stuff. I just write it just to show you guys my next steps. But you could honestly just skip to what I'm about to write. So it's going to be sine theta cos theta plus sine squared theta all over cos theta cos theta. And then if you combine all this together, you should get sine theta cos theta plus sine squared theta cos theta. And then we see that that's the exact same thing as the right side. Left hand side equals right hand side. So sometimes I see some students try to pull a fast one on the teachers, and I promise you it never works. Like sometimes some students, for example, would get up to this red step where you see like the red stuff, then they would write left hand side equals right hand side. Like don't do that. Like you need to show that the last sentence of each line is the exact same thing. So here, I think we're almost done the lesson. Oh no, we have 2 more pages. So recall from the previous lesson, the Pythagorean identity, this is the equation sine squared theta plus cos squared theta equals 1. This is the case for any variable, whether that's like sine squared heart or sine squared star or anything like that. Like honestly, I could even say sine squared 1000, like it would just equal to 1. It's just a rule. So here, that's just like a little recall note. That means we're going to use it somewhere here. So divide cos squared x plus sine squared x equals 1 by sine squared x. So we just replace theta with x in this case. So here, cos squared x divided by sine squared x plus sine squared x divided by sine squared x equals to 1 over sine squared x. So here, what do we notice? Cos squared x times sine squared x. This looks familiar because if you recall, cotangent is equal to cos times or cos over sine. But you might be like, Kaylin, there's a square here. Does that mean there's going to be 2 of these? No. It's not a coefficient of 2, it's an exponent of 2. So here, this is now going to be, wait, hold on. Yeah, it's going to be cotangent squared x. Because if you think about it, if these are squared, that just means it's like cotangent theta times cotangent theta, right? So this is cotangent squared. If it was cos to the power of 3x, sine to the power of 3x, then it's going to be cotangent cube x, right? It just depends on what it is, but what's important is seeing cos over sine. Now, some students, or you might not see this in the exam, but let's say if I gave you cos squared x divided by sine squared x, not 2, a 1, this does not equal cotangent squared x because there's only a single 1 here, right? This is going to be equal to cos x over sine x times cos x, which is the same thing as cotangent x times cos x. That's what it equals to. So in order for it to be a full cotangent, they have to have the same exponent. And if they don't, then you have to break it up like this. So here we can continue. Sine squared x over sine squared x, this cancels to become 1, equals 1 over sine squared x. So we know 1 over sine is equal to 1 over cosecant, but there's a 2 here, so that means it's going to be cosecant squared. Or wait, I wrote that wrong. It's not 1 over cosecant, sorry. It's just going to be cosecant squared x. And then now, that's it for this question. So here we're going to do letter B. It's the same thing, but now we're going to divide by cos squared x. Go here. The first ones cancel. Sine over cos, that's related to tan, so this is going to be tan squared x. The 1 over cos, the reciprocal of that is going to be secant. And then, if you wanted to, you could rearrange these formulas. So for example, like let's say we look over here. If you wanted to solve for cotangent squared x, you would just move the 1 over. And yeah. So example 3, this is like the other ones we saw on the previous page, where we set up our t-chart. So now we see that there's more than one denominator for more than one term on both sides, so it doesn't really matter which one you start with. I'm just going to change the left side. So here, 2 sine squared x minus 1. Let me think about how I would approach this. What I would do is I would check on the left side, that's what I choose to start with. What can I change here? What can I rearrange that would make the most sense? So here, if I'm looking at this, my options for this to change would be either the sine squared x or the minus 1. If I were to change minus 1, I would get sine over sine, cos over cos, something like that, right? But if I were to do that, I feel like it's going to be a lot more complicated. So what I'm going to do instead is I'm going to change the sine squared x into something I know. So if you recall, at the top here, we actually said sine squared theta plus cos squared theta equals to 1. That means sine squared theta is going to be equal to 1 minus cos squared theta. So I'm going to change this sine squared theta into this identity at the top. So here is going to be 2 bracket 1 minus cos squared, not a theta, it's an x. Do not make that mistake. If you write a theta out of nowhere, you're going to lose half a mark for that. Minus 1. And then now I'm going to proceed from here. So I'm just going to FOIL the 2 and see where it goes. So honestly, don't try to plan out everything right from the start. It helps, but if you take too much time thinking about it, you might get stuck. So just try stuff out, and more times than not, it just works out. So here, I'm just going to try foiling out just for funs. So it's going to be 2 minus 2 cos squared x minus 1. Now if you notice here, we have 2 whole numbers, so the like terms are 2 and negative 1. If we combine those, that's going to be 1 minus 2 cos squared. Oh wow, my brain just forgot how to write an s and a 2. Cos squared x. And now, right away, we see that we got the right-hand side right there and there. So we say left-hand side equals right-hand side. And looks ugly. I'm going to change it. No. Left-hand side equals right-hand side. Alright, so now we're on letter B. So here is going to be 1 minus cos squared x times tan, or sorry, not tan, or a plus sign, but it's multiplied. Tan squared x. And on the right side, it's cos squared x. I think it's easier to change a complicated looking part of the equation to an easier side than the other way around. So here we have 1 minus cos squared x tan squared x. We're going to change tans into sines and cos. So 1 minus cos squared x is going to be times sine squared x cos squared x. And then this is what gets a lot of students. They see 1 minus cos squared x and they think, oh, this part here is going to be the same as sine squared x equals 1 minus cos squared x, and they convert that. But this is a question that tries to trick students, because this cos squared x actually being multiplied by the terms in the brackets. The 1 minus part is actually a separate part of it. So here, if we ignore the 1 minus, these cos squared x's actually cancel, because they're being multiplied together. So now we're left with 1 minus sine squared x, and we know from the top for the Pythagorean identity, this is the same thing as cos squared x. And now left hand side equals right hand side. So we're on our last question. So here we have secant theta over tan theta plus cotangent theta. So secant over tan theta plus cotangent theta is going to be all over sine theta. Or not all over, it's going to be compared to sine theta. So now we're going to convert everything in terms of sine and cos. So this is 1 over cos theta. It's going to be all over sine theta over cos theta plus the opposite way around, cos theta over sine theta. And then now we want to combine our denominators together, because here we have cos as our denominator in this one and sine on the other one. So we're going to multiply them by their opposites. So times cos theta times cos theta times cos is on sine times sine theta times sine theta. So now this is going to be 1 over cos theta is all over sine squared theta plus cos squared theta all over sine theta cos theta. And then now this is going to be 1 over cos theta times sine theta cos theta. And we know from our identity that sine theta plus cos theta is the same thing as 1. So here, this is all really just 1. So I'm going to write this as 1 now. And then at this stage, we see the coses cancel, so we're just left with sine theta. And now, left hand side equals right hand side. So again, this part here is from this identity, the Pythagorean identity. And that's it for today's lesson. So your homework is going to be these trig identities, and it's up to you whichever side you want to change and alternate. This is going to be your homework. Please do at least half of them. But that's it for today's lesson.